Right, to simplify or break down a radical, you look at the number. If this is a radical symbol, and the number here is the index number, another thing that I could probably tell you is that this number is called, underneath here, is called the radicand. It is what we're going to break up. Now this is a square root. So since it's a square root, we're going to think what's the largest perfect square, and this one's been done for us, the largest perfect square that'll go into 72. Now, to talk about radicals, and we're just doing a review here, not doing a whole chapter or anything, but to talk about radicals, there is a great product rule with radicals, and there's not a sum rule, and there's not a difference rule, but there's a quotient rule that says you can break up the radicand into a product and then take the square root of them separately. You couldn't do that with a sum, and you couldn't do that with a difference. Not to confuse anybody, but what's the answer to that? Is it 7? 4 plus 3? It's not, is it? Because that's a grouping symbol, and you actually add them together and then take the square root. So there's not a sum rule where you can break them up and do the square root of 16 is 4, the square root of 9 is 3, and add that together. That doesn't work. You have to simplify. But there is a product rule where you can break up the product and say the square root of 36 is 6. And I had a teacher say, well, if you can take the square root of it, it gets to come out of the house. You know, it's just to help you remember, I guess. But once you take the square root of the number, it comes outside the radical symbol. The 2, you don't take the square root of, and it just stays underneath. Now, when you look at 72, to be honest, a lot of students would think this first. Right? 9, I'm going there. It's a perfect square. But what you have to recognize is that this number also contains a perfect square factor of 4. And what is 9 times 4? 36. Okay, so we're not going to do it that way. Think about the largest perfect square that'll divide into a number. Now, you can also have a coefficient with a radical, like this 4 is in front of the radical symbol, and so it is a coefficient. We break down 90, 9 times 10. The 4 just keeps coming along. And the square root of 9 is 3, and the 10 is not a perfect square. It's not 5 times 5, is it? A lot of people look at 10 and think, oh, that's a perfect square. No, be careful, it's not. 5 plus 5 is 10, but 5 times 5 is 25. So the 10 stays underneath, and then 4 times 3 is 12. Okay? Now I have found like factoring that it's so easy when you go over it, but when you start to apply it yourself, it gets kind of tough. So I'm sure we'll encounter some different problems. Square root of 48, again, the largest perfect square. You might think of 4. 4 times 12, but 12 has what in it? What's the perfect square that's going to 12? 4. Another 4. So that 4 and that 4 tells you that here's the 16. The 16 is the largest perfect square that'll go into 48. The square root of 16 is 4, and that 3 just stays underneath. We're simplifying a radical. Much like you would simplify a fraction, you wouldn't leave this, you would write this. So we wouldn't leave the square root of 48, we'd have to simplify or reduce it down. And they show you here how you use the 12, how, you don't, it's just add steps. So go straight to the largest perfect square that'll divide into a number. All right, before this, let's just practice a few. Just on that sheet of paper you got there, just on your packet if you want to, how would this number break down? Think about that. Largest perfect square that go into 200 is 100. 100 times 2, the square root of 100 is 10. Left underneath the radical is 2. Is that pretty easy? Okay. That one's pretty easy. Largest perfect square that'll divide into 27. 9. The square root of 9 is 3. And left underneath the radical symbol is this 3. Okay, square root of 128. Look at the largest one. Bigger than 4.
64.
Yes, 64. 64 times 2 is 128. The square root of 64 is 8. And the 2 is left in the radical. What is it?
No, that one is 25 times 2.
Mm-hmm. What is it?
It'll be 81 times 2 and then 92.
That's good. What is it?
16 times 2. And then 4 and 2.
4 root 2? Good. Square root of 98? What is that one?
Square root of 49 times 2 equals 7 square root of 2.
Let's just try a couple more. Alright, there's also a quotient rule, and it's great. You don't care what 16/25 is. You can actually break that up and do the square roots separately, and that would just be 4/5. Okay, so there is a quotient rule, just like there's a product rule. Not a sum or difference rule. How's it right now?
I put it down to 25 times 10.
Okay. And so that'll be 2 times 5 times the square root of 10. So 10 square roots of 10. Makes sense? Everybody good? What do you think about radicals so far?
Pretty easy.
No sweat? Okay. Alright, see if you can do your practice set. Practice set 7. Oh, that one's so.
What I tell you, Tootin? I'm just stupid. I know.
Hey guys. Okay. Good. Yep. You're number 3. Okay, hang on, I'm confused.
On my paper.
Alright, now, what you're saying here, if that 5 came out, is that 25 times 35 is 175.
That's right.
Alright, so that's one. Alright guys, let's be quiet please.
Oh, let me see what I think.
Okay.
Still not here. I gotta redo it.
Okay.
I'm not ready yet.
You're what?
I'm not ready. I gotta redo it.
Well, come on, we'll do it together. Alright, so since it ends in 75, let's see if 25 will go into it, and it does 7 times. So break that down into 25 times 7 under the radical symbol.
Okay.
No, like times 7 underneath the radical. Erase that 7 on the outside.
I hate this freaking board.
Okay, now.
Is that one?
Alright, that's good. Now that we can take the square root, we can bring it out. So the square root of 25 is 5. It comes outside, but the 7 stays inside. There you go.
I guess I just done it on my calculator.
Yeah, that's good if your calculator will do it for you, but we need to know how to break them down. I can throw some variables in there to show you why we need to know that. Alright, does anybody have a question about any of those 4? If your calculator will give you the answer for the 90, let me tell you, it won't give you the answer for this. So we start out with 90s and 121s and 175s just to learn how to break it down, so that we can do, monomials and not just constants later. What would happen here is you would break down your number, then you would break down your variables. Any even powers, a perfect square. Alright, what all would come on the outside of that? Well, all the perfect squares would come on the outside. So I would have a 3. What's the square root of x squared? X. What's the square root of y to the 4th? What? Y squared. I'll tell you the shortcut for that is to take the power and divide it by the root. 4 divided by 2. And then, so what stayed underneath? Now that's where they can go, but we're just starting out with small ones so that we can learn how to do the big ones later. Alright, let's try to be quiet while we're working some problems on the board. not a perfect square. 8's not a perfect square. But look at your problem. 16 is a perfect square. What square is 16? 4. Right, so what's this? Let's pretend like that was never there. So you just have 2 times 4. No, there's radicals not there anymore. Once you take the square root of the 16, your radical symbol is not there anymore. So it's just right. If you have a perfect square, just write down the answer. It's not here, is it? You don't have to necessarily put this first. So you brought that out and multiplied it by. Oh, I see what you're saying.
No,
I see what you're saying. You want to undo it? Oh, I see what you're saying now. I just write the perfect square first, so I see it. It's obvious, but you don't have to. You can write the other one. That's right. Here you go. Good job. All right, questions. Because the square root of 10, or 100 is 10. 10 times 6 is 60. $25 times 19 is 475.
He didn't.
You
So
did
what I
number
did-
9. Hey,
Oh, I did number 9, didn't
hey, I got this. You're good.
I? I thought it was number 9.
We're up home.
I thought you
I
gave me
like
number
it.
9.
I like how you wrote it right under number 8. But anyway,
Did you give me number 9?
it's okay. Move it over here.
I got number 8 too.
You can multitask. How about that? That work?
Yeah.
All right.
Can we do 8?
Sure. Since it's not been done. I didn't know where in the world you were, really. I was looking.
I thought you gave me number 9. Because you gave Allie number 7 to
Yeah.
start with.
And she's not here. Yeah.
Yeah, and then you
I
said
know.
I
It got
read it.
confusing there.
Is that one?
Uh-huh. No. Yeah. That's good. All right, does anybody have a question? I feel like about half of us understood real well, but I really don't feel like the other half maybe got it. So, does anybody have a particular question about any of those 10 problems?